on that ship. It's just gone. It's just going.
And now we're going to give the return address to Earth for aliens.
Spending 45 years travelling around the solar system takes its toll on a spacecraft. NASA's Voyager 1 mission, launched in 1977, entered what scientists call interstellar space in 2012, and then simply kept going. The spacecraft is currently 14.5 billion miles, 23.3 billion kilometres beyond Earth. While Voyager 1 is still operational, scientists on the mission recently noted that it appeared puzzled about its location in space without entering safe mode or otherwise raising an alert, which mystifies and frustrates the space probe team on Earth. But what exactly went wrong with Voyager 1, and what did it encounter in interstellar space? Join us as we investigate how, from the furthest reaches of space, Voyager 1 transmitted a confusing message back to Earth. The inspiration for Voyager came from the realization that several planets will be aligning in a highly convenient manner in the late 70s, providing a once-in-several-lifetimes opportunity to visit them all in one journey. NASA opted to launch 2 identical spacecraft, one after the other, since plotting a trajectory that hit all objectives flawlessly would be difficult and expensive, not to mention risky. The first would take detailed images of Jupiter and Saturn from close range, while the second would observe the 2 planets from a different vantage point before continuing on to Uranus and Neptune, assuming everything goes well. Everything, well, mostly everything, worked out as planned, and Voyager has been one of the most productive and surprising missions ever undertaken in space. As long as you're sending something into interstellar space, why not prepare it for the possibility of extraterrestrial interception? Moonshot doesn't adequately describe the ambition of the Golden Record project and the astronomically small odds of it ever being encountered by intelligent life. But that isn't really the point. The Record and Voyager have encouraged generations to believe that it is worthwhile to explore and attempt new things just because we can and because it is part of our DNA. The very human contents of the Golden Record were curated by Carl Sagan, among the most humanitarian of scientists. The idea that our unique presence, from our biology to our ideas of beauty and philosophy, is blasting through outer space is awe-inspiring. Early in their journey, 4 decades ago, the Voyagers surprised scientists by providing the first close-up views of Jupiter and Saturn's moons, revealing the existence of active volcanoes and fissured ice fields on worlds that astronomers had assumed would be as inert and crater-pocked as our own moon. Voyager 2 became the first spacecraft to fly by Uranus in 1986, and Neptune 3 years later. So far, it is the only spaceship capable of making such missions. Now, as pioneering interstellar probes more than 12 billion miles from Earth, they're surprising and baffling theorists with a series of unexpected discoveries about that unexplored region. Their remarkable odyssey is finally winding down. Over the last 3 years, NASA has turned off heaters and other non-essential components, eking out the spacecraft's remaining energy reserves in order to extend their historic missions until about 2030. It's a bittersweet time for the Voyager's scientists, many of whom have been working on the program since its start. They are now confronting the end of a project that far exceeded all their expectations. "We're at 44.5 years, says Ralph McNutt, a physicist at the Johns Hopkins University Applied Physics Laboratory, APL, who has devoted much of his career to the Voyagers. So we've done 10 times the warranty on the darn things. The Voyager 1 spacecraft was the second to visit Saturn. It investigated the planet and its rings, moons, and magnetic field in more depth than Pioneer 11 could. Except for the tests intended for its photopolarimeter, Voyager 1 accomplished all of its objectives. The spacecraft discovered 3 moons, Prometheus and Pandora, the shepherding moons that maintain the F ring defined, and Atlas, which shepherds the A ring in the same way. Titan, Saturn's biggest moon, was discovered to have a thick atmosphere that obscures its surface from visible light cameras and telescopes. Spacecraft instruments showed that it is mainly nitrogen, similar to Earth's atmosphere, but with a surface pressure 1.6 times higher. The spacecraft also photographed the moons Mimas, Enceladus, Tethys, Dione, and Rhea, exposed the intricate features of Saturn's complex and magnificent ring system, and discovered the G-ring. Just as it utilized Jupiter's gravity to help it reach Saturn, Voyager 1 used Saturn's gravity to change its direction and speed, giving it a trajectory that would take it out of the solar system. Voyager 1 became the first spacecraft to enter interstellar space in August 2012. If we define our solar system as the Sun and everything that orbits it, Voyager 1 will remain within its bounds until it escapes from the Oort cloud in another 14,000 to 28,000 years. In the middle of May, Voyager's Attitude Articulation and Control System, AACS, which is normally responsible for maintaining the high-gain antenna pointing towards Earth, began sending jumbled data to Earth instead of the regular reports about the spacecraft's health and condition. From our vantage point, it seemed as though the spacecraft had developed an electronic kind of aphasia, a disorder that causes the loss of fluency in one's speech. According to a NASA statement at the time, the information may seem to be generated at random or to not correspond to any potential state the AACS may be in. Engineers were even more perplexed that despite the spacecraft's unusual status reports, the radio signal from the ship remained strong and stable, indicating that the antenna was still directed at Earth and not in whatever position the AACS was stating to NASA. Similarly, Voyager 1's science systems continued to gather and send data as well, with none of the weirdness impacting the AACS, and whatever was wrong with the AACS did not prompt a fault protection mechanism, meant to put the spacecraft in safe mode when there is a malfunction. Fortunately, NASA engineers were able to detect the problem and implement a solution. They found out that the AACS had been sending telemetry data via an onboard computer that had ceased operating years before. All NASA engineers had to do was issue the instruction to the AACS to utilize the right computer to send its data home because the dead computer damaged all of the outgoing data. The next hurdle will be determining what prompted the AACS to swap systems in the first place. According to NASA, the system most likely got an incorrect command from another onboard computer. While this is not a serious issue for Voyager 1's well-being at the moment, the real culprit will need to be located and repaired to prevent future anomalies. For the last decade, Voyager 1 has been coasting in interstellar space, further than the reach of our Sun's magnetic field. The field has provided the craft with some protection from cosmic rays and other interstellar radiation, similar to how Earth's magnetic field protects us from high-energy particles and radiation from the Sun. When one of those high-speed energy particles impacts a computer chip, it may create minor memory faults that mount up over time. And it's realistic to expect that to be a concern for Voyager 1's onboard computers as well. A mystery like this is sort of par for the course at this stage of the Voyager mission, said Suzanne Dodd, project manager for Voyager 1 and 2, in a statement. The spacecraft are both about 45 years old. This is considerably above what the mission designers expected, and we're also in interstellar space, a high radiation environment in which no spacecraft has ever travelled. We'll have to wait and see what new dangers and surprises await Voyager on its next mission. Looking back, it's been 45 years since NASA's Voyager spacecrafts launched from Earth, yet the twin explorers continue to communicate with Earth from billions of miles away. We make the "Hello, are you okay?" call once a week, according to Suzanne. The check-ins allow Voyager 1 and Voyager 2 to communicate their precise positions on the other side of the heliosphere, a vast area of the solar system whose magnetic field protects Earth and the other planets from galactic cosmic rays. In one of these calls in May, Voyager 1 delivered a strange signal in which data from the computer that regulates its orientation returned in jumbled bits, scrambled ones and zeros, and it continued to seem like garbage. "It's like the check engine light turned on," said Bruce Wagner, a JPL engineer who controls the Voyager mission's operations. "We couldn't pin it down to a specific area. This computer is crucial because it maintains Voyager 1's communication antenna securely oriented in the direction of Earth. Any failure or loss of power would permanently cut off humanity's longest distance conversation. Voyager 1 is now so far away that it takes over 22 hours for communications from the probe to reach us, but they're worth the wait. The messages include important scientific information regarding interstellar magnetic fields, plasma waves, and cosmic rays. The Deep Space Network, a trio of huge radio antennae in California's Mojave Desert, Australia, and Spain, receives transmissions from the Voyagers. They're spaced out throughout the world so that at least one of them may be pointed at any point in the sky. Each of the 3 locations has a 230-foot antenna developed particularly to listen to the Voyagers. The further they travel, the more difficult it is to hear them. The radios aboard the Voyagers transmit messages at just 23 watts of power, and by the time those signals reach Earth, they have been reduced to the lightest of whispers, barely 1/billionth of a watt. Every year, the spacecraft's batteries lose up to 4 watts of power owing to the decay of plutonium-238, the radioisotope that powers them. Because the sun is so far away, solar energy is not a possibility. With a restricted supply of energy, what can be forfeited and what can be maintained is a series of trade-offs, and why Voyager 1 made the transition in the first place is still a riddle worth solving, since it signals something else isn't quite right on board the probe. What are your thoughts? Tell us in the comments, and if you enjoy watching our videos, please subscribe.